can't do this. We'll see. Okay. Alright guys, so here it goes. For this first problem, hopefully everyone wrote out the equation correctly, because if you didn't, that's where you would have had your first problem, okay? I think everyone, raise your hand if you got the limiting reactant part down. That's what I thought. Everyone is like a pro at that, that's amazing. So doing the limiting reactant part out, we figure out that AgNO3 is the limiting reactant, which is going to become a really important factor later on, okay? So now that we know what the limiting reactant is, we have to figure out what the ions in solution are going to be. The first problem that people came up with is, well, what ions am I looking for in the first place, okay? So you have to take a look, and you have to tell yourself, okay, AgNO3, Connor, AgNO3 is the limiting reactant. That means that all of the Ag in the limiting reactant is going to turn into the solid, okay? So if all of the silver turns into the solid, will there be any silver floating in solution? No, there will not. So we do not have to find a concentration of the silver, okay? However, if you guys look at what is left over from the silver nitrate, the nitrate compound, it comes over here, and this is a solution that's still aqueous. The KNO3 is aqueous, and that stays in solution the whole time. So we are absolutely going to have to find the K plus and the NO3 ions, because they stay in solution the entire time. They never make the solid at all. Okay, so those for sure we're going to have to make. And then we have to take a look at what else is in the solid. Okay, if you look at the solid, we have our silver. We already talked about the silver, but we also have CrO4. This guy was part of the excess reactant, which means that it's going to react with the limiting reactant. The limiting reactant will run out, and there will be a little bit of K2CrO4 unreacted with the silver. So that means that there's going to be a little bit of CrO4 still floating around after all of the solid has been made. So that tells us then that we have to find our CrO4 2- ions as well. Questions so far? We're good? Okay, so now let's go about doing it. The first two ones that I started with were the spectator ions, because they were the easier ones. So if we take a look at the K+, that's one of the spectator ions. We take the volume of the K plus solution multiplied by its molarity over liters. And then, guys, a lot of people were getting tripped up by the next step I do here. These first two steps multiply to get me moles of K2CrO4. This step right here looks at the ratio within the formula, and in this formula I have 2 Ks for every 1 mole of K2CrO4. I know that because of this little subscript right here. Okay, so that's where this ratio comes from. It does not come from the equation up top. It comes from within this compound. Okay, so from within this compound, I know that I have 2 moles of K plus for every 1 mole of K2CrO4. So that tells me then, if I multiply all this out, I will have moles of K plus. Are there questions so far? Okay, the question of the problem was asking is what the concentration is. So I have to put this over the total volume, the new total volume of my solutions, because keep in mind, I added 150 milliliters to 100 milliliters of solution together to make this vessel reactive. So that means that total volume, those two solutions together add up to 250 milliliters, which is why I put it over 250 milliliters, and I got this as my concentration for my K+. Raise your hand if you also got that as your answer for the concentration of K+. Fantastic. Okay. Same idea goes down here for the NO3- ions. I start with the volume of AgNO3, multiply by its molarity, and then I take a look. For every 1 mole of AgNO3 I have 1 mole of NO3-, and that's because of the ratio between the two compounds. So that tells me then I have 0.075 moles of NO3-. Put that over the total volume, and that gets me my molarity of my NO3-. Raise your hand if you also got that as your answer for NO3-. Alright. Lastly is the slightly tricky step, and guys, once you get it, it makes so much sense, and you're like, oh my gosh, this was so easy. But here it goes. We have to figure out what's left of the CrO4-, okay? Or the CrO4 2-. To do that, we have to figure out how much of it reacted to make the solid in the first place. So to figure out that part out, we have to start way back with the silver, okay? The reason I'm starting with the silver is because I have to remind you, we have AgNO3 is the limiting reactant, so that means however much silver there is determines how much of the chromate ion reacts with it. So that's why it's important to know how much of the limiting silver we have. Okay? So we can look back at this calculation right here to figure that out. This was how much volume of our AgNO3 multiplied by molarity of AgNO3. And then if you guys look at this ratio, we have a 1-to-1 ratio between Ag and NO3 as well. So I could have just as well written moles of Ag on top here and gotten the same answer of 0.075 moles of Ag. So that's what I used down here. So because it's a 1-to-1 ratio, I know I'm starting with 0.07 moles of silver. Okay? So I've got 0.07 moles of silver. I also, this is going to be important in a second, I also have to figure out how much of my CrO42- I'm starting with in the solution. So I take my milliliters of that solution, multiply by the molarity, and then for every 1 mole of K2CrO4, I have 1 mole of CrO42-. So that gets me moles of CrO4- that I'm starting with. Okay? So now that I know what I'm starting with, I take what I have of the silver, and then I take a look at the mole ratio, and this is in the solid product, okay? The solid product is Ag2CrO4. So in the solid product, I have a 2-to-1 ratio of silver to CrO4, which is why I have this ratio the way I have it. So I take however much of the silver I have to start with, multiply by the ratio of the 2 parts of that compound, and I figure out how much CrO4 was used to react with that much silver. Questions? Okay, so now I know how much was used to react with the silver. Now I take what I started with, which is what I calculated right here, subtract what I used, which I calculated right here, and I have what's left in terms of moles of CrO42-, put that over my total volume, and I get my concentration. Okay? It seems like a lot of work, but I'm breaking it way down for you. Once you guys get it, you can fly through these. I'm just doing it the slow way so that you guys can see all the steps. Carrie.
So I understand your last step of the subtracting, but from the part where it says to find all the way to that, I don't understand any of it.
Let's see. So to find here?
Yeah.
Okay, so do you get that we have to know how much silver there is in the solution first? Like why we have to figure out how much silver there is? The reason we have to find out how much silver there is because this silver runs out first.
Yeah.
And the silver is what's reacting with the CrO4.
That controls how much you have of the CrO4, right?
Correct. It controls how much you're reacting of the CrO4. So because it's controlling how much we're using of the CrO4, we have to know how much we're starting with of the silver. Okay? We also have to know how much of the CrO4 we have in the first place. Okay. So that's why we do this calculation right here. Okay, so this is figuring out how much we have in the first place. This is figuring out how much we use to react with the silver. And then we did the starting minus the used. Okay? Alright, so
why does that give you the amount it starts with though? Like I understand the steps you take, but I don't know why you do those steps.
Because we want to remember our end goal is to figure out how much is still left floating around. So if we need to know what's still left floating around, we have to know how much we started with versus how much we used to see what's left floating around. Does that make sense?
No.
No? I would suggest maybe watch, if this actually recorded, to go back and watch this. And I'm always here doing lunch and after school too. Okay, yes? Sure.
So we found in the first, like the very first step that CrO4 was limiting.
No, you found that AgNO3 is limiting.
So
right.
That's the one we have to watch with Ag since it shows up in the solid.
Right.
Okay. And then, but what if we just find like the 0.075 and get the equation with the 0.075 equation instead?
Like if you started with, yeah, that would be fine. Yep. Okay. Any other questions, guys? Are we good? When did we get out of here? We have got like 45 minutes, I think, so that's good. Okay. All right. So here we go. Did that record? Oh, I don't even know what that means, but I'm gonna stop.